This lecture is over covalent bonding and it's titled Sharing is Caring. It says sharing is sometimes more demanding than giving, and you've got Mary Catherine Bateson right there. So, what we want to do is we want to look at our learning goals, and our learning goals are that you understand the nature of a covalent bond. Now, a covalent bond is going to be quite a bit different than an ionic bond, and because it's quite a bit different, it's also going to have very different properties that we're going to look at. So, students, you should be able to distinguish between not only covalent and ionic, but within covalent bonds, you should be able to distinguish between what's called a polar and a nonpolar bond. These are very different as well, and we'll talk about what makes a polar and what makes a nonpolar bond. You should also be able to remove from the name to the chemical formula and the chemical formula to the name for covalent compounds as well. That's very similar to ionic bonding, but it is a little bit different, so we need to make sure we go over the rules. Okay, so first of all is a covalent bond. We learned last time that ionic bonds are formed when you actually take an electron and you remove an electron from one side to the other. Okay, so this thing right here gains an electron, it becomes negative. This one lost an electron, so it becomes positive. And then the attraction between the positive and negative is what's called an ionic bond. A covalent bond's a little bit different. What it is it says we've got a pair of electrons that are you can think of it almost like an ice cream sundae here, and it's being shared between these two atoms, where this one thinks it's getting those two electrons, and this one thinks it's getting those two electrons. So because of that, you have this covalent bond that's a series of shared electrons between two atoms. So, in order to look at covalent bonds, one of the first things we need to do is we need to review electronegativity. We covered electronegativity earlier this year, and we said basically it's the measure, it's how much an electron or an atom wants an electron. And we said there's a couple of things that it depends on. It depends on the distance from the nucleus, so the distance between the protons and the valence electrons. It also depended on the number of protons, and it also depended on the stability of the ions. And as a result, we said that electron negativity increases as you move up the periodic table, because you have more access, you get closer and closer to that nucleus, and it increases as you go across the periodic table because you have less what are called shielding electrons. But basically, what this means is electronegativity has the atom with the greatest electronegativity is fluorine. Okay, we exclude noble gases from these because remember, noble gases, they're happy, they don't want any electrons. So instead, the most electronegative element is fluorine. The least electronegative element would be cesium down here because it doesn't want an electron. It wants to get rid of its electron as much as possible. So now that we've taken a look at electronegativity, we can go back to our idea of covalent bonds. Covalent bonds always occur between two nonmetals. Okay, remember, whenever we have nonmetals, we're looking at something on the periodic table that is to the side of this particular step ladder right here. So it's to the right of boron, silicon, arsenic, and tellurium. It's this group 14, 15, 16, 17, and to some extent 18, although we won't talk about those in this case. So covalent bonds are formed between two nonmetals, so the right side of the periodic table. The molecules have a defined shape. So in other words, it will be a triangular shape, or it will be a tetrahedral shape, or it will be a linear shape, unlike an ionic compound, which kind of has a diffuse shape and it can change relatively easily. Whereas ionic bonds tend to be solids at room temperature, covalent bonds tend to be gases or liquids at room temperature. Covalent bonds have a low melting point, contrast that with ionic bonds, which have a high melting point, and they have a very low boiling point as well, contrast that with ionic bonds, which have a high boiling point. So if you look, the ionic and covalent bonds are kind of opposites of one another. One has low, one has high. One has a defined shape and one doesn't. You need to know to be able to distinguish between the covalent bonds and the ionic bonds. So the first thing we have, it says covalent bonds have a much lower melting point than an ionic bond. And it says, using Coulomb's law, explain why. And so we need to get into a little bit more about what a covalent bond is. But basically, what you have is you have two atoms that are sharing an electron. Now, I've drawn them as just atoms. Those aren't oxygens, but we'll just say, oh, we can say they're oxygens for this particular case. And actually, we won't. We'll say it's atoms A and B. Okay, atom A wants these two electrons, and atom B wants these two electrons. Well, it turns out atom A could have a slightly bigger pull on these electrons than atom A. than atom B. So as a result, these electrons tend to gravitate towards atom A. When they gravitate towards atom A, we say that it is partially negative. And that's what this symbol right here means. It's kind of a Greek letter, but it means partial. And then you also have here, well, the electron is kind of moved away from this B, so we say it has a partial positive charge. Now, if you look, you have a partial positive charge and partial negative charge, and we know from Coulomb's law that these opposite charges will attract. So, if you have this opposite charges that attract, it should be similar to an ionic compound. But the difference is the fact that it is a partial positive and a partial negative. Because of that, it's not as big as when you have an ionic one, which is a full positive and a full negative charge. These two are going to be attracted to each other more strongly because they are complete charges. Okay, this is just a partial charge. It could be something like 0.001 charges. But as a result of that, there is a small attraction. So using Coulomb's law, we can say because the charges are greater in ionic bonds, then the attraction between the two is greater. So draw what happens to the electrons in a covalent bond between chlorine molecules. So the first thing you would realize is these two chlorines, they want to share an electron because this one right here has 7 electrons and this one has 7 electrons. And what they would like to do is they would like to each have 8 electrons. So what they're going to do is this chlorine is going to kind of offer this electron over here, and it's going to kind of go in between the two. And this chlorine atom is going to offer this electron to kind of go between the two. And what results is you have chlorine, and you still have your 1, 2, 3, 4, 5, 6. And you have chlorine. You have your 1, 2, 3, 4, 5, 6. And then you have 2 electrons that are in the middle. And those 2 electrons that are in the middle are actually what we call the covalent bond. What you see is this chlorine thinks it's happy because it thinks it has 8 electrons. This chlorine right here is happy because it thinks it has 8 electrons, even though they're sharing these two in the middle. Okay, these right here represent what we call the covalent bond.